Welcome to our physics lesson 2, and the topic is linear motion, form 3. So we are doing the topic linear motion, form 3. This is lesson 2. In lesson 1, we saw the definition of linear motion. Then we also defined the terminologies like speed, displacement, velocity, and distance. So you are having a good base for this lesson. We talked about distance, we talked about displacement, we talked about speed, and the sister to that, velocity. Okay? So velocity is the last thing I talked about in lesson 1, the rate of change of displacement. Okay? So speed and velocity can also be uniform. In what sense? If in uniform speed we shall have equal distance in equal time intervals, the motion is such that it covers equal distance in equal time interval. Then it will be uniform speed. Otherwise, we talk of average speed. Okay? We can talk of uniform velocity when a body covers equal displacement in equal time interval. So that displacement is what I want you to know. Displacement is a figure and a direction. A figure and a direction. Displacement. So if I'm moving on a straight line, I cover 10 meters in 5 seconds. I'm still facing the same direction. Again, after 5 seconds, the next, I start my clock. Again, it covers 10 meters in 5 seconds. The direction is the same. Okay? So we can see equal displacement in equal time interval. Okay? So after 5 seconds, I stop. I check the distance covered. Since that distance is in a particular direction, then we call it displacement. So displacement is made up of distance inside, because you can measure the length. The measuring of the length gives you distance. And if it is in a particular direction, we talk of displacement. I hope you get that clear. So we can also talk of uniform velocity. A body covers equal displacement in equal time interval. Okay? So today let us look at two things. One, acceleration, and two, we shall be looking at conversion of units. So what is acceleration? Is the rate of change of velocity. The rate of change of velocity. So basically, we are talking of velocity change over time taken. And the velocity change is final velocity minus initial velocity over TA. I want to put TA to signify the time taken in that change from U to V. That is the time taken that this body changed its velocity from 40 km per hour to 60 km per hour in 10 seconds. You see? So that 10 seconds is what I refer as TA. Got it? TA is the time taken for that change to be experienced. Using the letters, final velocity is V, initial velocity is U, so velocity change is V minus U over the time taken for that change. So TA is time change between U and V. Okay? Now, a few things that you have to note. When velocity decreases with time, the body is slowing down. When the velocity decreases with time, the body is slowing down. Okay? This is called negative acceleration or deceleration. So, I am coming from what background? V minus U is positive. Then we say the body is accelerating. E.g., 40 meters per second, it is increasing. Within 10 seconds, it has reached 60 meters per second. Okay? 40 upway to 60, and that change happened in 10 seconds. So if I ask you to calculate acceleration, you will say V minus U over TA. Then you substitute 60 minus 40 divided by 10. 60 minus 40 is what we call velocity change. In what time? In 10 seconds. So when I divide by time, I get what we call acceleration. Okay? Now, I reverse. I want to stop. Okay? I want to stop, or I want to negotiate a corner. So, it was at 60, and I've placed the brake pedal. So the vehicle is slowing. Its speedometer reads now 30 meters per second. Okay, so I'm at 60, I'm slowing, and I can read now 30 meters per second. Okay, and that happened, let us say, in 5 seconds. Okay, from 60 to 30. So what is my V in this case? 30. What is my U? 60. So what is velocity change? 30 minus 60. What do you get? Negative 30. That change from U to V happened within 5 seconds. So if I'm to calculate acceleration, I will say A is equal to V minus U over T. 30 minus 60 divided by 5. So it is negative 30 divided by 5, which is negative 60. Negative 60. Okay? So that negative 60, that negative acceleration, it is an acceleration that happened to be negative and not positive. So that negative acceleration, in another language, it is known as deceleration. So when I talk of deceleration, I've already taken care of that negative, a sign. The signs negative and positive are attached to a specific meaning in physics other than being mathematical operation. The four major operations: addition, subtraction, addition, subtraction, multiplication, division, major operation in maths. But positive and negative, they have further meanings depending on the context you are talking about. For example, if I take going right is positive, then going left is negative. That negative, in layman's language, is opposite. Okay? So opposite to the sign you had initially. Right, the initial sign is positive. So opposite of positive is negative. Opposite of right is left. Opposite of up is down. So there is a word, a meaning attached to these signs. So if I write for you, for example, 30 minus that. If I write that, for example, maybe we focus. If I write for you this, don't read for me 30 minus 60. No, you are used to that. You can live with it. But it is 30 subtract negative 60. That's correct. Language, mathematical language. Because we use this not on the same level with that. That should give you a sense that these things are not the same in pronunciation. And they carry significant weight in your mathematics or in your understanding. Subtract. This is negative. This is negative 60. Okay? Right. So, I want us now, having concluded those terminologies, let us look at some aspects of conversion. The SI unit of velocity, speed, is meters per second. Okay? So, the SI unit of acceleration will be meters per second per square second. Again, we don't say meters per second squared. No, that's not physics. The physics is meters per square second. Okay? There is a difference. Now, we may be given kilometers per hour. You know, we are studying about motion of bodies. So when a body moves, that motion may be expressed in kilometer per hour. But suppose we want to work with SI unit. What would we do? It would mean we change kilometer per hour to meters per second. So you ask yourself, 1 kilometer has how many meters? 1,000. This hour, change it into minutes. That is times 60. Then each minute change it to second, again times 60. That is where we are. So this 60 converts hour to minutes, and this converts minutes to second. So the entire figure here is what is used for conversion. If I have 72, if I have 72 kilometer per hour, then what do? If I want to change into meters per second, what do? I take 72 multiply by, I would take 10 over 36. That is a multiplying factor. Another student will take 72 times 1,000 over 3,600. You are correct. Another student will take 72 times 5 over 18. He is very correct, or she is very correct. Then what does it give me? I picked 10 over 32 because I know 36 goes in 72 twice. Becomes easy. So this gives me 20 meters per second. So very important aspect. When you are trying questions now, if you take your physics book from 3, go to an exercise, do some 3 questions pertaining to what I have talked. Okay? You have done acceleration, you know it. I've done conversion, you know it. Other things that may be tested, your ability to get distance, your ability to get displacement. Remember, displacement, you can get it using a ruler or using any measuring device, or at this level from 2, you can use Pythagoras, depending on the way the motions are laid out. Remember, length using measuring device. Number 2, Pythagoras. That is how you get the lengths. Okay? Soon, you can also get using SOHCAHTOA. SOHCAHTOA. Those are formulae that deal with lengths. Pythagoras, SOHCAHTOA. At Form 2, you are done. Direct measurement, Pythagoras, SOHCAHTOA. Okay? When they ask you about average velocity or average speed, know that is the total distance over time taken or total displacement over time taken. Displacement, you have to be very careful. You analyze. Is a straight line joining starting point and end point. If I move from point A in a circle until I come back, the displacement is 0. Okay? Acceleration is change of velocity over time taken for that change. Okay? So there are some questions you can get which will require bit of input, especially questions that are given, like you are given speed and you are given distance. I moved at this speed and covered this distance, so you must get the time taken. I'm given also another portion of the journey with its distance, speed B, distance B. You have to get time taken so that you can get now either average speed or velocity using total distance or total displacement over total time taken. I think you have enjoyed. Get the book now and try to do. Lesson 3, I will try to explain graph that represent various motion. Subscribe so that you get more stuff. Tell your friend, you keep on revising. You don't know when will Corona end. When you get this YouTube, comment if the writing are not clear. I may not repeat, but at some point I can give you the tips. But so long as you hear me, you should be able to note down a few things here and there. Subscribe for more. Bye bye.